All right, welcome class. Uh, Today we are going to be looking at one of the topics which you are very much familiar with, and this is about polymers. You've heard about uh, polymers like what? Uh, like polythene and polyester and the rest. So we want to look at the science behind these things you're going to be calling polymers. You're going to see that even in the first part of the course, we dealt with some things which are going to be which are also called polymers, but we do not define them by that word. So let us see what you're going to be calling polymers. Yeah. So the polymers you're going to say it's a material of just a minute. Uh, what are you going to say to be the polymers? Um, is it to be like a very large molecule, or it's like in science there's a word called macromolecule. So it's like a macro molecule which is made up of repeating units joined together by covalent bonds. A macromolecule, which means it's a very large molecule, and it is made up of repeating units, which you're going to be calling monomers. So, in other words, you're going to say a polymer is made up of repeating monomer units. Monomer units, which are repeated. So, but you're going to get more of that definition in your notes. This video series is not meant to replace the notes, but it's meant to supplement the notes. So, so now we're going to look at, we're going to look at the exact definition uh, from here, from your notes. But so I think that the polymer is made up of repeating units of a unit which we are going to be calling monomer. And now we're going to say that this fundamental unit which we are going to be calling monomer, it can either be natural, it means that it is found in nature, yeah, or it can be synthetic, it means that it's been made in an industry, it's been man-made. Yeah, so synthetic, man-made, which makes a bulk of the polymers that are available. But later, what you're going to say is that uh, there are very, very few of synthetic polymers which are biodegradable. So the thing is that the synthetic polymers are easy to make, yeah, but they are essentially, most of them are something which you can call indestructible, yeah. But that means that there's some which can be combusted, but for a good number of them, once you make them, they'll stay in the environment for years, and that has been the problem which led to the banning of the single-use and the polythene, as you are aware, a couple of years back, yeah, because of the fact that they are just ISO, they're just building up uh, in the aquatic environment, in the landfills, and other things. So those are the issues. Synthetic polymers, easy to make, but essentially indestructible. Natural ones, they are available in nature, and they are easily degradable by microorganisms or bacteria which are available in nature. Yeah. So okay, so you're going to come uh, to the polymers as they're available in nature, but I think uh, we're just trying to give some definitions. You're going to see that you're going to be defining polymers by their type. In this case, you're saying there are some polymers. These are the ones which you may know, like for the basin that you use for washing and the rest, or even something like what. If I may use, once again, I'm not advertising any company like, but in this case, I've got a container like this one for cooking fat, like for example. You may see that you may be able to actually put it in a piece of fire, and it's just going to melt. It can melt, and you can mold it, and you can mold it into another shape. So the thermopolymer, or they're called thermoplastic. By the way, now we introduced a word here. So the plastic is like the synthetic polymers. I'm going to call it plastic, yeah. Uh, or I could have called it thermopolymer, but I'm just using uh, thermoplastic. In this case, you're going to say these are the ones which can easily be the polymers which can be affected by heat. Once you heat to a certain temperature, they melt and they can be molded. And then once you cool it, it becomes hard again, and you can use it for whatever purpose. Yeah. And then there are some uh, which which are used for certain purposes to give uh, structural strength. And these ones, no matter how you heat them, they will never melt. It means that they melt during the process of manufacture, which are going to once again you're going to see it in the notes. It means that uh, it's similar to like a thermoplastic. Once you heat it, it melts, and then through that one you add another chemical which is going to bring cross linkages between one chain of a polymer to another one, and therefore these chains, they prevent this compound from okay, let me say it undergoes an irreversible change to which the chains cannot slide or they cannot move, so they are totally rigid in a way. A compound, I mean, a plastic such as like this one of switch here, once you made it into whatever structure, like in a mold which was used for melting, once it sets in a process called curing, yeah, there's nothing you can do about it. Perhaps you just discard it in nature if it breaks, but that is the end of it. Yeah. Once you make it, once you set it up, once you set it during the manufacture, during the something a process called curing, that is the end. Yeah. And then there's some polymers or some plastics which which can stretch similar to the rubber, which you are very much aware of. What you're going to see is that this is a natural polymer which is called latex. Yeah, yeah, which you add sulfur to because the natural rubber is sticky, but if you add sulfur to it, you can make it rigid, vulcanization as it's called, and therefore you can be able to make use of it like the tires and the rest. Yeah, yeah. So there is the elastomers which can stretch, and then once you release them, it gets back to the original set, elastomers. Then there is the thermoset, which once you set them, nothing you can do about it. Then there is the thermoplastic, which you can melt and remold. Now, there is also another classification of the polymers regarding the type of the monomers which are used for uh, in the manufacture or in the synthesis of the polymers. In this case, there is the homopolymer. It means that this is a polymer which is made from one monomer, the one which is repeating. I've given an example of what we found in the topic called carbohydrates. Cellulose and starch, they are made up of glucose as the repeating units. So it is the repeating unit which depending on how it is joined, I think you need to get back to the notes that in the cellulose the glucose is joined through a glycosidic bond in a horizontal manner, as opposed to a starch, it is joined vertically, yeah? And and the enzymes in the body can be able to distinguish between cellulose and starch. But but the repeating unit is what? Is just glucose. This is called a homopolymer. Most of the almost all the other polymers that you're going to encounter, they are copolymer. It means that they are made up of more than one repeating unit. Yeah, and these ones can be further classified into random, just like protein. Protein may not be, for example, you're going to see protein is made up of amino acids. Yeah, and the amino acids like glycine, alanine, all the rest. Yeah. Uh, Let me not get into those names because in this course I'm just trying to avoid you cramming. Yeah, so you'll be able to get the names. So um, they may not be in a specific pattern. So in this case, we are saying these copolymers, they can be said to be random. Yeah, like proteins are made up of different combinations of 20 amino acids. Yeah, so this one can be said to be random copolymer. Uh, in trying to make polymers, you can have a case in which it is made up of just two monomers. Maybe there is A, then it is being repeated B, A, B. So in that case, it's said to be alternating. One monomer and a second monomer, they're just being repeated. So in that case, it is alternating. As the name implies, for the block, it means that you can have maybe like 3 units of A and then probably 4 units of B, three units of A and another one of B, just to get certain properties. Yeah, yeah. So in this case, depending on the properties that you want to get for that polymer, you can know how you're going to repeat one monomer and then the second one. This is called block copolymer. And then the last classification is this one, grafted. As the name implies, I think it's something which you've learned in biology, that you can have a tree of what? Of lemon, and then you can be able to do some okay, in one of the branches you can be able to using some nutrients to try to get probably a what? Uh, uh, is it like a branch or like something like a leaf of a different plant, like where, like what? Th that was lemon. You can put an orange, for example. You can be able to graft it. I'm not going to all those kind of things. And then once you close whatever you've made and then let it grow, you're going to see that you're going to have a different plant growing onto the branch or the stem of a different plant. This is called grafting. So in this case, you can have something like A, and then there's a branch of a B polymer, a block of it from a certain length. So in this case, you're going to say that the branch of B is grafted onto the chain of A. So this is called branch copolymer. Now, the polymers can also be classified by the way in which they are made. As I mentioned in this course on chemistry B, we just try to avoid reactions and mechanisms. So in this case, we just try to keep the mechanisms to a minimum, and just try to say that there are two ways in which polymers can be made: by something called step growth or condensation. Condensation, it means just like the ones which we're dealing with here in protein. Yeah, you've got one amino acid uh, which is losing OH, and the other one for the amine, in which the amine is losing hydrogen. So you're losing a molecule of water, which is called condensation, and then you're joining the two amino acids to call the peptide. Yeah. So in that case, as I mentioned, we dealt with that mechanism for the making of the peptide, which in the longer chain is called the protein. Yeah. So that's called step growth. And then there is a new type of mechanism which I'm going to call a free radical mechanism. A free radical is shown by by a dot. As you you know, electrons, they for the mechanism that you've been dealing with, or for the structure that you've been dealing with, like for water, uh, the electrons are shown by as lone pairs. But in this case, you can have a case whereby you've got atoms of the same polarity, like oxygen and oxygen. So you can be able to have a bond break, in which case the atom, each of the atoms which are making up that bond ends up with one electron. Yeah. Like in this case, I've got something like peroxide. A peroxide, just like hydrogen peroxide, is similar to water, but it's got an extra oxygen. Yeah. So the bond between the oxygen and oxygen, because of the lone pairs, that bond can be weak and it can be easily be broken by 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 something like ultraviolet to form two radicals, which have represented the RO plus RO giving 2RO. Yeah. So I've just tried to avoid showing the two lone pairs. Yeah. So in this case, this is just representing two radicals, and then one radical. I hope you can be able to see very well. I think I hope it's a bit clear on the board. So one radical, like in this case, it can react with a gas like ethene, which I've represented. Ethene is made up of a double bond. A double bond is made up of a covalent bond, excuse me, uh, a sigma bond, and then the pi bond is made up of two unpaired electrons. So I've just tried to illustrate those two unpaired electrons as one electron and one electron on this side. So the free radical plus one of the electrons from the pi bond are going to form a covalent bond, which I've shown here. Perhaps I can represent this one in red here. That's the new bond which I've formed. So the unpaired electron will form your new radical. So this new radical is going to attack your second alkene to form another new radical, and that new radical is going to attack the unreacted alkene to form another radical. So in this case, the chain will continue growing with forming a radical of a longer length until there will be no more starting material. Then you're going to have two radicals, like I've got this radical plus another radical of the same. Yeah, I'll just show it on this other side. So they're going to join together to form a covalent bond. Yeah. So this covalent bond is made up of one radical and another radical. So two radicals are going to join together to form a covalent bond. All of these things are being shown in your notes. So there is the initiation, yeah, initiation, where the radical is being produced, and then the radical is reacting with your alkene to form the first radical. That's the initiation. And then there's the propagation, in which you're forming radical being long, being extending the length until there is no more starting material. So that is propagation. Then the joining of the two radicals when there is no more starting material, that's the termination step. Yeah. Now, there's something I may need to really show. Let me just take this so that I can get the board here. I mean this cleaner. And that is if this is like the chain of okay, let me put it like this. 1, 2. Okay, this is just like a small chain here. I'm just trying to say maybe this is like the overall chain. What you're joining is if I've got this free radical and then this one as your alkene, what you're joining is two carbon atoms at a time. So there is this one here, there's that here. So you can say that 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 this chain can be represented as RO, and then there is, like in this case, I can say there is this one I put in bracket and then I put an 3, yeah? It's being repeated how many times? 3 times, yeah? Can you see that? So, but 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 this repeating unit can be can be very long. So that in this case, it can be put like an N, yeah? Where N can even be 10,000, 100,000, and the rest, yeah? So in this case, scientists have found a way of just representing your polymer by the repeating unit. Are you seeing that? So from this repeating unit, which is put in the bracket and then you put an N, it represents the general repeating unit of the polymer. In this case, so from the notes you will see different characteristics of the groups which you can put here. For example, for something like the one for the polyethylene, it means that polyethylene is the polymer which has been formed from ethylene as being the repeating unit. The the atom here is hydrogen. There is hydrogen. There is hydrogen, and then there is hydrogen here. You understand? So in this case, that's the repeating unit. But you can get a case whereby uh, there is this structure which I'm going to be calling this alkene, which you're going to be, and then there is something like a benzene, yeah? Like this molecule, it is given the common name of styrene, yeah? So the repeating unit, it will be called, you're going to have this one as the repeating unit, yeah? And then you're going to have the benzene, and then I put an N here. So this is going to be called like the repeating unit. So this general structure is a structure of something you're going to be calling poly, and then you're going to put the word styrene, yeah? You understand? So from the notes, you'll see the different general representation of the polymers, yeah? So I believe with that one, you'll be able to look at the notes and just read about uh, the various uh, uh, applications of polymers, and particularly there are some new type of developments, especially with the concern about biodegradability. You're going to read about biodegradable plastics. Yeah, you're going to see them at the end. Like there is caprolactone, polylactic acid, and the red. So you'll see something about biodegradable plastics. Yeah, and this in your notes, so you'll be able to look at that one. So I think that's the much I'll talk about polymers. Yeah. But once again, this video series is not meant to replace the notes, but to supplement the notes. So the notes in soft copy, I believe, are self-sufficient, but they're made in such a way that you'll be able uh, to understand. But in case if you don't understand, then you can look at this video and you can be able uh, to to just relate with what is in the notes. So I believe you'll be able to look at uh, at the at the soft copy of the notes and be able to really understand what is in those notes regarding polymers. So I think I'll just stop there regarding this lecture series on polymers, and I hope you really enjoyed it. Yeah. Okay. All right.